Hey, Algebra 2, we've reached section 13.5. We're going to be talking about the law of cosines. Our vocabulary today is the law of cosines, and we see the law of cosines written in this key concept right here as a way of managing or as a way of relating, rather, the side lengths of a triangle with the cosine of one of the angles. So I know that you guys hopefully watched that video that I suggested to you about the derivation of sine and cosine laws. You can see that video right here, and it's kind of an old video, but it was by Mathematics Online, and so they do a really good job of deriving the law of sines and the law of cosines, which is pretty cool. Not too hard for you to understand, so definitely make sure you give that a look. With that in mind, let's go ahead and talk about how to use it. So now when we're dealing with the law of cosines and law of sines, the way that we're going to use the law of cosines specifically is we will use it if we do not have one of these things. So notice that we could use it to find side A, if we had. So if I wanted to find side A, I'd need to have angle A and angle C side C and side B. So notice what you need to have in order to get the value that you're looking for. And also I could use it to find an angle given that I had the lengths of all the sides. So in example 1, we're going to solve a triangle given two sides and an included angle. So you see what we have here. Technically, let's write down what we have and make note of what we don't have. So I jotted our halves and what we're looking for right over here down. And so what I want you to observe is that the angle that we're given is angle C. That should really help us narrow down which formula we're going to use. We go back to our law of sines. We see having angle C and sides A and B can provide us with side C in this form. So let's go ahead and use that. Notice that this looks an awful lot like the Pythagorean theorem, a squared plus b squared equals c squared, except we subtract 2 times a b times cosine c. That's just a way that I try to remember it. So if I'm looking for side b, it's b squared equals a squared plus c squared, but then I'm subtracting, notice the b's on both ends, the cosine of b times 2 times ac. All right, so we're going to be using this last one that I'll write down here. C squared equals a squared plus b squared minus 2ab times the cosine of C. All right, and so we'll use that to get what we want, which is side C. So C squared is equal to 18 squared plus 24 squared minus 2 times the product of 18 and 24 times the cosine of C, which is the cosine of 57. And so you know how I like to make everything calculator ready. So C is equal to the square root of all of this stuff there, and with a little help of a calculator app or a calculator, we're going to get C equaling approximately 14.49. Here in this example 2, we're asked to solve the triangle, and we know what that means. It means that we'll find, of course, all the values of each of the sides and each of the angles of the triangle. And so what I'm going to do is put down the information that we have, and then we're going to go and find the information that we need. So we have all of the side lengths. We need to find the angle lengths. So how can we do that? Well, let's go back to any one of those formulas. We remember C squared is equal to a squared plus b squared minus 2ab times the cosine of C. Let's write that down like that. So here we see that we can use side C to actually calculate the cosine of C. So we can use sides C, A, and B to calculate the cosine of C. So let's go ahead and solve this equation first for C, or at least the cosine of C, and see what we get. All right, I'm saying a lot of C's there. So C squared, if I subtract A and B, it's going to be a squared minus b squared. So I'm subtracting it from both sides, so it goes away. And then when I move this whole thing over, well, I really can't just like with addition and subtraction. But what I can do is divide both sides by negative 2abc, right? Negative Nope, I can't put the C there because that's not a true statement. My bad. Let's get rid of that. So negative 2ab. So I'm not subtracting, but dividing that away. Y'all stay with me. And that's equal to cosine C. And if I wanted to get even more fancy, C is equal to the inverse cosine or the arc cosine, or however you prefer to put it into your calculator of this. And we'll talk about the difference between arc cosine and inverse cosine at another time. But yeah, for our intents and purposes, this should be fine. So this is our calculator ready formula once we plug in the values. So this is our plugged in version. I'm going to go ahead and put it in my calculator. So with that, I get that the measurement of angle C is 17.85 degrees. Now, I can go back through and have fun and do this all again, but honestly, I probably would like to use a little bit of law of sines, law of cosine, law of sines probably to get out of my jam. But okay, let's go ahead and practice using law of cosines for now. So finding angle A would require me to use the law of cosines. A squared is equal to B squared plus C squared minus 2 times BC times the cosine of angle A, okay? And so now I'm going to solve this similarly as I did for the other problem. I'm going to solve for angle A. So angle A would equal the inverse cosine of this expression here, and I'm going to plug in the values for that expression so we can evaluate. So here is my substituted value. So after calculating this, we get that the measure of angle A is 138.9 degrees. And if we have the measure of angle C, and we have the measure of angle A, it won't be too hard for us without any of this trigonometry to calculate the measure of angle C. So, angle B. So let me go back up here and put this down. So this is 138.9. This is 17, let's say 17.9 here. And let me go ahead and calculate this. And I get that the measure of angle B is 23.2. So here is our solved triangle ABC. Here's a handy reference guide to let you know what situation is best for what. So we're going to be talking about oblique triangles. These are non-right triangles. So if it has no right angles, then you need to know the measure of at least one side and any two other parts. If the triangle has a solution, then you must decide whether to begin solving by using the law of sines or law of cosine. So this is a great chart to do that. If you've got two angles and a side, you want to do law of sines. Because if you have two angles in any side, then you really have three angles in a side, right? If you have two angles and an angle opposite of them, if you have two sides and an angle opposite of them, and that's of one of them, that was the situation where we had angle A, and side B, then we want to use law of sines. But if we've got two sides and their included angle, law of cosines works. And if we have three sides, again, law of cosines works. So this is pretty handy. We're going to get to our last example. Finally, a medical rescue helicopter has flown from its home base at point C to pick up an accident victim at point B and then from there to the hospital at point A. The pilot needs to know how far he is from his home base so that he can decide whether to refuel before returning. How far is the hospital from the helicopter's base? So here's the situation that we're dealing with, and you guys hopefully can see that this would be a wonderful opportunity for us to use law of cosines. So in this case, we're looking for side A, and we have angle A, so you know the situation should be, let me get a pen that works in a size that makes sense. We should have A squared is equal to, remember, B squared plus C squared minus 2 times AB times the cosine of A. All right, so that's how I remember it. I don't know if that's helpful, but all right, so now let's go ahead and do it. So A squared is equal to B, in this case, is 50 squared plus C, which is 45 squared minus 2 times the product of those two large numbers there. 45, and then times the cosine of A, which is 130 degrees. And of course, calculator ready is always important. Let's square root all of that stuff. And then I'm just going to put it in our calculator. Hopefully you can try it too. Make sure you know exactly how to use your app or calculator, and we'll come up with the answer in just a second. So what I'm getting is that that distance is 86.125 miles, and so that's the information we have. The pilot needs to know how far he is from his home base so that he can decide whether to refuel before returning. I don't know if that's what the pilot needed to know, to be honest. I'm just saying. You guys let me know what you think, because honestly, if he's got to fly or she's got to fly here and then fly here, doesn't the pilot just needs to know the sum before? I don't know, unless we're trying to fly back. Who knows? Who knows what's happening? All right. Anyway, we found the answer, la 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 la, and hopefully it's making sense. Law of cosine feels a little bit more concrete because we don't have that little play with the sine where the sine of two angles could fit a situation depending on some circumstances. We don't really have that with law of cosines. So sometimes the law of cosines, though cumbersome, is a little bit more satisfying. Let's talk about that later, and you can tell me if this helicopter really should have done what it. Do we really need to calculate this for the helicopter pilot? All right, take it easy, guys. Let me know if I can help you with anything. Take care.